Now, you've probably seen a film where somebody places their hand on a biometric scanner and it opens a security door. And I thought that was kind of a cool high-tech effect for use in an escape room game. So I decided to make one. And in this video, I'll explain how you can make one too. So the scanner app itself is running on a tablet here, and that connects wirelessly to a controller behind the door. That controller has a relay which is supplying power to this maglock, and that's what's keeping the door securely closed. Now obviously I'm only using a scale model of a door here, but this would work exactly the same way in a full-size door or in a panel on a secure container or something like that. And the app itself isn't really a biometric scanner. This is just a basic Android tablet, so it doesn't have that kind of hardware installed. And even if it did, that wouldn't actually make a very good escape room puzzle if players just had to place their hand on the screen. So what I did instead was to create a number of different interaction points on the screen. And as I place my fingers on them, hopefully you can see numbers appearing above them that correspond to the order in which I place my fingers on those points. So what this effectively is a sequence puzzle, and players need to work out the correct order to place their fingers on the screen. Now the order I've got here is actually thumb and then the fingers in order, and as I place my last finger on the screen here, I want you to watch the door. As I get the sequence correct, a wireless signal is sent to the controller and the door pops open. So let me go into a little bit more detail about how I made this. So the app itself is written in a game development engine called Unity. And I've used Unity in some of my previous projects. You can use it to create games for consoles and mobile phones and for PCs, but here I've deployed it to an Android tablet. And as I mentioned, this is not a state-of-the-art tablet at all. This is an original Galaxy tablet. So this is about 8 years old, I think. But it does have multi-touch available on the screen. It'll actually detect up to 10 finger touches on the screen. And so here, like I say, I've placed hotspots at the end of the fingertips, but actually you could customize this to be any kind of touch. So you can have a panel of buttons that players need to press in the order as well. And it has built-in Bluetooth and Wi-Fi capability as well. And that's what I'm using to connect to the controller. So the controller itself, this is quite sort of neatly packaged up down here. So this is a Wemos D1 Mini. That's very similar to an Arduino, except it's using an ESP8266 chip. And that has built-in Wi-Fi as well. So that's the way that I'm communicating between these here is actually wirelessly. If I was using an ESP32 here, I could use Bluetooth instead, for example. Now I've got a relay shield which is neatly stacked onto the top here. So this is a 5-volt relay module which the Wemos activates, and then I've got a 12-volt power supply which is going to the maglock, and that's what secures the door. Now, just in terms of the hardware, this is probably the simplest project I've ever done. I mean, it hardly seems worth showing you this diagram, but just to be explicitly clear, here I've got my Wemos D1 Mini, and I've got the relay shield stacked on top of it. So you don't need to worry about connecting the ground and the 5-volt and the signal lines. That's automatically done for you. And then here I've got the 12-volt DC supply that's going to power the maglock. You can see I've got the positive terminal connected to the normally closed output of the relay. I've got the common terminal of the relay going to one side of the maglock, and the other side is connected back to the DC power supply. Now, the much more interesting things in this project are happening on the software side of things. So let's take a look at that. So to create the scanner app itself that's running on the tablet, I'm using Unity. Now, I've used Unity in other projects in the past, but if you're not familiar with it, it's a game development engine. Now, what that means is that it's a program that runs on your PC, and it combines code and graphics and sound and game logic and allows you to build them into a game that you can run on another device. And in fact, those other devices, you can run them on PCs, Macs, Android, Apple devices, PlayStations, Xboxes. So lots and lots of different target devices. I'm using Android here, but if you've got an iPad, you could just as easily deploy to that instead, or a tablet that's running Windows. And it's even got a kind of a built-in simulator here, so you can see what it's going to look like on different devices. But the way to create a game using this, it's a little bit like setting up a movie set. Imagine yourself as the director of a film, and the first thing you need to do is to place your props and your actors into the scene. So we start with the scene view at the top here, and in the hierarchy console on the left hand side, these are all my actors that I want to have in my scene. I've got my camera here. That's going to tell me what the player is actually going to see, so the kind of the point of view that they see. And then my actors, I've got the canvas, that's in the background, so that's for displaying 2D elements. That's got the background on it, which has got this kind of texture here. So this is just a JPEG file which I added into the project. So you can see here under my textures and sprites, I've got various images which I imported. So I've got the background of my scene. Then I've got the handprint itself, which is slightly nearer the front of the camera than that. You can see that's actually a semi-transparent ping which I imported here, overlaid on the background. And then I've placed my my hotspots where the player can actually touch on. So I've got one on the thumb and one on each of the fingers. But obviously this doesn't have to be a handprint at all. You could create any kind of image you wanted here with different places that the player needed to touch on. And you can simply drag these around the scene. It's a very easy interface to use, a kind of a drag and drop interface. You can make these areas larger or smaller or reposition them however you want, really. So I've got those, and then I've also got a little panel at the top here that's got a text element on it, and I've got a panel at the bottom with some text on it as well. So that's all of the kind of the actors that I've placed onto my scene, and then what I need to do is to tell them what to do. So again, much like in a movie set, the actors need to have scripts to follow. So I've got a couple of different scripts here. I've got one called Touchpoint and I've got one called Hand Scanner. Now Touchpoint is the simpler one to start with, and you'll see that my thumb and each of my fingers, if I look over the inspector here, they've all got this script attached to them here. So this is a script which just these elements have been told to follow. If I double click on it to open that script up, we'll get Visual Studio, which is the default code editor, loaded up. Although it's loading the wrong window, let me drag that across. So you can see this is a really straightforward script to follow. It's just got two elements. It's got one called onPress and one called onRelease. And when it's pressed, it displays the number of touches that there are present on the screen, and it also just prints a little debug message. So debug.log in Unity is very similar to serial.print in the Arduino IDE. That's just what you can do to display a little console message to track what's going on. And when it's been released, the onRelease button here will blank that text out again. So what this script does here, this is responsible for creating the numbers above the touch points to say which finger touched them. And I can show you that if I switch to the simulator view here, and I'll click the play button to actually start running the game, as it were. When I press my mouse cursor down, that simulates a touch on the screen there, and you can see that this one symbol above here, that shows that it was the first finger that was pressed there. Now unfortunately, one of the limitations about the simulator is at the moment it's only possible to simulate a single mouse press at once, because it's just corresponding to my mouse click. But you'll just have to take my word for it that if I held my mouse button down here and then pressed another mouse button here, we'd have the number 2 come up, and then this one as well, number 3, just as I showed you in the real life application. So that's the first script. That's nice and simple. That just creates some sort of graphical feedback elements basically. Now to actually get the whole of the rest of the logic of the game, well, that is running on this hand scanner script here, and that script is actually attached to the camera object. So you can imagine this being the kind of the script that the director of the film follows. It's not actually telling any of the individual actors what to do. It's mainly like the entire script for the film itself, or for the application in our sense. So if I double click Hand Scanner, we can load up that script. We can see it's a little bit more meaty, but this controls all of the rest of the logic of the application. It's all contained in here. So the structure of the script here, we're writing in C# here, which is a little bit different from the C or C++ you might be used to from using in an Arduino, but actually it's not too tricky to follow, and there's a lot of similar concepts in Unity than there are in Arduino. So we start off at the top with some declarations and some variables, just as we would do in an Arduino script, where we kind of normally declare some global variables or some constants. That's what we're doing here. But what we're doing is declaring some references that are public or sometimes serialized, and what that means is that they will appear in the inspector here. So, like I say, Unity kind of combines a graphical drag and drop element of arranging things on the scene and being able to relate items together by dragging them into slots here. And it has that as well as having code here. And the way that they link together is by exposing variables as public or as serialized elements. And that means that they will appear in the inspector on this side here. So what we want to do is we want to have a public array of game objects, which we're going to call the solution. And that's what this box is here. So to define the order that we want the players to touch their fingers in, what that means we can do is we can drag the game objects that we want in the order that we want them to appear into this array that's exposed in the inspector. So the actual solution I had to start with was thumb, finger 1, finger 2, finger 3, finger 4, but you can change that to whatever you want. If you only want to have, let's say, 3 fingers in the solution, we can click the minus button here, and that will reduce the size of the array to just have thumb, finger 1, finger 2. So that's what this purpose of the script here. By making it public, what that means is that it exposes it in the interface here, and you can then use graphical drag and drop onto it to define the solution you want. We've then got some serialized fields, which are the top panel text and the bottom panel text, which we see here and here. Now the point of these is that we're not really expecting people to change them. They're more a way of defining a link from what that part of the scene is, so that this script is able to edit it later on. Let's say that the hand scanner script wants to write some text up here. It wants to say access granted, or it wants to say access denied later on. Perhaps we want to send some other text to the player to say, you know, place your hand when ready. The hand scanner script needs to know how to address that element in the scene. So that's what the references here are for. We can actually take the top panel text from the hierarchy and we can drag it into this slot here. We've done the same with the bottom panel text here. And from then on, this hand scanner script has got a reference to them, so it's able to change those values later on. So that's why we've got these serialized fields here. We've then got an audio source. Now this is a private variable declaration here, because we don't want people to drag other audio sources into this. We actually just want to get a reference to the audio source component on here. I'll show you how we do that in a moment. But we do have 2 public audio clips, which are going to be the sounds that are played when the scanner is successfully activated or where it's failed to be activated. So again, I'm using 2 free sound effects, which I downloaded from FreeSFX here, and they are contained in my assets at the bottom. So I can click on those and I can just click play, and you're able to hear what those sound like. And then to assign those to the success and failure, I'm literally just dragged those into these slots here. So hopefully you can see, even if you've never used Unity before, it's got this very easy way of assigning different variables to things that once the code is set up, You can, let's say I had a whole folder of audio clips here and I wanted to try out what different ones sounded like in the game. I can just drag them in and replace them in that slot there. It's very simple to do. Back to the code again. The next thing we have is a string, which is the IP address of the door controller. So this is so that we're able to make that wireless request to unlock the door when the puzzle is solved, when players have placed their fingers in the correct order. So you see I've hard-coded an IP address there, and that's going to be the IP address of the Wemos controller, which I'll show you the script for that in a moment. And then we've also got another array of game objects, and this is going to be the guess that the player made. So we defined the solution already up here, and down here we define the guess that they made, and of course what we're going to do is to compare the array of objects in the guess to the array of objects in the solution, and if they match, that's how we know that players pressed the buttons in the correct order. Okay, so at the moment obviously that list is currently empty, but as players touch things on the screen that's going to fill up. And in fact I can show you that happening by, again, if I go back to the simulator and click play, when this is running, you'll see at the moment we've got, so the array of guesses has filled up with 3 elements, which matches the number of elements in my solution at the moment. And when I press down on something, you'll see the guess here, the first element of the guess, fills up with the object I touch with my finger. And again, if I were able to simulate multi-touches at this point, if I then touch another one, you'll see that the second element down here would match this. So that's what's happening as we touch these different things here. They're filling up with the game object that I touched, and we're going to compare it ultimately to the solution. If I actually, let's get the solution down to just having a single element in it, which is element 4, and I'll take the guess down to match it. If I now touch element 4, you'll see that that is correct. It says access granted, because now my guess matched the solution. So that's how the things work, and just sort of show you happening in real time there. Let's go back to the code there. So we now have the touch and the release buttons here. So this is the script that actually, if I try to just magnify the size of this a bit so you can make it slightly easier to read. If I could remember what the zoom in button was. How do you zoom in on... Oh, there we go. So I realised that it's probably a bit easier to read if I do that. So we've got the touch and the release button. So this is what assigns the touched object into that array of guesses that I was just talking about. Start, well, this is the function that is called when the application first loads. So again, this is really similar to setup in an Arduino script. It's just called once at the beginning, and we use it to just do some initialization. We set the value of that top panel text. So this is what I was describing earlier. Because we have assigned a component from the scene into this slot here, that means we can now set the value of what that displays by just calling toppanel.text. And we initialize the guess with an array of game objects that's the same number of elements as the solution has. And we also grab a reference to the audio source component. So our camera has an audio source that's down here. Audio source is a component that's responsible for creating sound effects in a Unity game. And it has lots of settings here, but you don't really need to worry about these. I've left all of these as the default. The only setting we're going to be doing is to assign a value to the audio clip and then playing it. And the value of the audio clip we'll use is going to be one of these two that we had in the script here. So it's either going to be the success or the failure. We'll assign to that audio clip and then we'll tell it to play it. So that's how we're using that. So then we get into update, and again with the analogy to an Arduino script, update is exactly the same as the loop function. So this just goes round and round for as long as the application is running for, and this deals with the main the sort of logic of the game. So the first thing we need to do is we need to work out how many fingers there currently are touching the screen, and we get that by grabbing something called the touch count property from the input control. And then what we do with that value, well, that depends exactly what state the application's in at the moment. If it's idle, which is its kind of default state, so it's just, sitting there waiting for input, what we'll do is we'll update the panel of text at the bottom of the screen, and we'll say how many fingers are currently being scanned at the moment. So we'll fill in that blank with the number of fingers from up here. If the number of fingers that are touching the screen is equal to the number of fingers that have been defined in the solution that we're looking for, that's when we can now check whether those fingers were correct or not. There's no point checking if players have got 5 fingers in the right position if there's only 2 fingers on the screen, full stop. So we only actually bother checking the solution when we know that there are the correct number of fingers on the screen, and then we go into the scanning state. So then when we're in scanning, well, that's this section here. And what we do is we'll just send a debug message, we'll update the text that's at the top of the screen, and then this is the section where we loop over all of those objects that were in the guess array down here. So remember, at the moment it's empty, but this was filling up as I touch the screen, as I let go of things. This changed elements in the array here. We're going to loop over all of them. We're going to compare the value. Well, first of all, we're going to make sure that there isn't a null value in the guess array. And if it's not null, we're going to test whether it equals the object that was in that position of the solution array up here. We're going over all of them. Now, while we go over that loop, if any of those guesses does not equal the solution, then we know that they're not all correct. If we go all the way through this loop and every one of these guesses has passed, that means that we know that there was a value in every element of the guess array, so we know that they weren't null, and we also know that they did equal the solution, so that means all correct is true. So I've used this kind of structure of loop in the past. It might seem a little bit unintuitive because rather than saying are they all correct, what we're saying is any one of them incorrect? It is logically the same, it's just a different way of testing it when you're going through a loop. If we get all the way through that section there and the all correct flag is still set to true, well, that's where we can do our unlock routine. So we'll debug with a little message. We'll assign that audio clip that I was talking about. So we'll send the successful audio clip to the audio source, and then we'll tell it to play that clip. We'll update the text at the top of the screen. We'll change the status of the thing. And we also do this thing here called start coroutine send unlock trigger. I'll show you more about that in a moment. That's the thing that actually makes the wireless request to unlock the door. The reason why we do it in a coroutine, so you can imagine a coroutine as being a little bit like a separate thread. It's not actually a thread, but it's a bit like it. It's something that can run alongside the logic of the main script here. Again, with Arduino programming, you might be familiar with the idea of delay, and you might also be familiar with the idea of delay not always being a good thing. So let's say you were flashing an LED, so you turned it on and then you delayed for 1,000 milliseconds, and then you turned it off, then you delayed 1,000 milliseconds, and that would work. You get a flashing LED. But the problem is, while you're executing that delay, the entire program stops. And if you've also want to check for input, or if you're also monitoring some of the sense or something, that's not really a good thing. So there's lots of examples of how you can achieve pauses in your code without using delay. And this is a similar thing in Unity, basically. We want to perform an action that might take some amount of time to perform because we're making a wireless request, but we don't want to delay the rest of the execution of our code while it does it. So that's why we use what's called a coroutine to run that kind of alongside the main execution of the code. So this else here, this is what we get to if they were not all correct. So the player has placed 5 fingers on the screen, but they didn't match the solution array we were looking for. Well, in that case, that's a failure. We'll play the bad sound effect, and we'll tell them that they failed, and we'll set the status accordingly. Okay. Now, whether it was successful or whether it was failed, what we do then is we actually wait for all of the fingers to be released from the screen before we reset the puzzle. So in this case here, if number of fingers equals 0, and remember that number of fingers was what we grabbed right at the top here based on the touch count on the screen. So when there are no fingers touching the screen anymore, we'll go back to the idle state. Likewise, in the failure, if the number of fingers is 0, we'll go back to the idle state. But until that's the case, this is a little bit like a loop that will just go round and round and round, and it won't do anything else until they've totally removed their fingers from the screen, and that will reset the puzzle for the next game. Now, I did mention I would talk about this send unlock trigger, so that is what's happening next. So this is the coroutine that is going to be executed when the puzzle is solved successfully. So what are we going to do? Well, we're going to create a URL, and we're going to create a URL based on the IP address of the door controller that was assigned here. Remember, we typed an IP address in here, and that's going to be the IP address of the web server that's running on the Wemos next to the door. And we're going to append to the end of that a parameter that's going to describe whether we want to write a low or a high signal to the relay. Now, for the relay that I'm using, this is an active low relay, so I'm going to write a /L after it. But this could actually be anything you want at all. I'm just using L and H to represent low and high because it's convenient and it's short. So we'll basically, what we're doing is we're going to a web page essentially that is 192.168.0.169 /L. Okay, and we will create a web request here, and we will send web request here. So this is all built into the Unity networking library to try to retrieve that web address. And when we do that, what we do is we'll read the result. If it was an error, we will display the error on the bottom panel of text. Or if it was not an error, so if it was successful, we will display the output on the bottom text panel instead. So this is actually not required at all. This is just giving visual feedback based on what the results returned from this URL was. The thing that actually unlocks the door is literally calling that web page. That's the thing that's going to do it, and I will show you that script in a moment as well. Now, just as a matching function for this, so here I've got send lock trigger, and I've also got send unlock trigger, which you'll see is exactly the same, except that instead of having a /L there, we've got a /H. And if you wanted to make this a more generic controller, you could actually turn these two functions into the same one and simply pass a parameter to it that said the address that you wanted at the end. And you can, you could send whatever values you want. You could send numeric values. You could send, strings that represented some kind of input that the user had made in the app. But just for clarity in this one, like I say, I'm calling them as two distinct functions, lock and unlock. One calls L, one calls H, which represent the low and high values that we want to assign to the relay, which is going to unlock or lock the maglock. And that's actually the end of the script. And here's the code that's running on the Wemos D1 Mini. So this is going to run a web server on the local wireless network, and the Unity application on the tablet is going to connect to that server and make a web request with either the H or the L parameter, and that's going to correspond to either a high or low signal being written to the relay. The relay in turn is then going to either energize the maglock or de-energize and release the maglock, and that's what's going to either secure the door or open it. And all of that is going to happen in under 100 lines of code. So let's start again at the top. And we start with two external libraries at the top, which I'm including in my code. And these are both part of the ESP8266 platform, which is the chip on which the Wemos D1 Mini is based. So if you're using the Arduino IDE, as I am, and you have included support for ESP8266 target boards like this, you'll find that these libraries will be already installed, ready for you to use. I'm using two of them. The first one is the Wi-Fi library, which lets me join existing wireless networks. And the second one is enables me to let the Wemos D1 Mini act as a web server that clients can connect to. Then we go on to constants. So these are variables which are going to not change throughout the duration of the code. And the first two relate to the wireless network which I want to join. So for this puzzle to work, we need the door controller script here and the Unity Android application to both be connected to the same local wireless network. I mean, theoretically, it would be possible to call an IP address that was outside your local network, but I wouldn't recommend you create an escape room that can be arbitrarily controlled from any client on the internet. So I'm going to make the assumption that they're both connected to the same local network, and you simply supply the name of that network and the password required to connect to it. So just as you would if you were connecting on a laptop or a mobile phone or anything. We also define the pin that is going to be driven high or low to control power to the maglock. If you're using the relay shield, like I am, that kind of slots on top of the D1 Mini, that will automatically be connected to pin D1. If you're using just a regular relay module, you can obviously plug that into any of the GPIO pins you want. And we're also going to assign a length of time after which the lock is going to relock itself after it's been unlocked. Now, this is something you might want to configure depending on exactly the type of maglock you're using. So whether you're using a fail-safe or a fail-secure maglock, and also whether you are securing kind of like a cabinet door that pops open, or whether you're securing a door that players can actually enter into a new area and get locked within. You might want to adjust the behavior here. But the behavior which I want to have is that the door is opened by a trigger received from the tablet. So the maglock is released, the door pops open, and then 5 seconds later, so 5,000 milliseconds elapses, and then I want that maglock to energize again so that next time the cabinet door is closed, such as when the games master comes in and resets the game at the end, that is automatically going to relock again. We don't need the lock signal to be sent from the client to relock it. We'll actually automatically relock it here on the controller itself. But like I say, you might want to edit that behavior slightly depending on the exact setup that you're using to secure your door. Then we go on to the globals section. So these are variables which are going to be shared between several functions in the script. We actually start off by creating our web server instance, and we're going to use port 80, which is the standard port used for HTTP communication. We're going to create a variable to keep track of the last time the door was unlocked, because that's going to be used in conjunction with this delay to determine whether it's time to relock it again. And we'll also just keep track of the controller to say whether the door is currently locked or unlocked. Now we're going to define two callbacks. Now, callbacks are kind of functions which are automatically called when a certain event occurs. And the two events that are going to potentially trigger this is when the Unity application connects and it requests something from the web server. We're either going to display a page back over HTTP, or possibly it's going to request something that doesn't exist, in which case we're going to send back a not found error. And if you have done any kind of web page coding in the past, you might be familiar with HTTP error codes. So you'll see the 404 code in the not found error there, and that relates to a page not found error. So I mean, this shouldn't happen, to be clear, because the only thing that should be connecting to the server here is our Unity application, and that's only going to request one of two things, which is the H page or the L page, both of which should be handled correctly. But just in case anything goes wrong and something unexpected happens, we can send back a not found error and a 404 error code, or in any other case we can send back a 200 code, which is a success code to the calling browser, and we'll send back a tiny little web page. Essentially, this is some HTML code here. We'll just display a little heading, and we'll actually put two buttons on the page here, which are going to call high or low. So you can imagine this being kind of nearly like a manual override, if you want. If you were to connect to the Wemos D1 Mini web page itself, and you could do this either from any browser. In fact, you could do this from a mobile phone or your PC or whatever. Anything that is connected to this same local wireless network, we could come to the IP address of the Wemos D1 Mini and we'd see displayed a little kind of override page, as it were. So these two callbacks are going to be called in a moment. We'll see when. But first of all, we go on to the setup function. So this is called when the script first runs. We'll initialize the relay pin as an output, and we'll start off with it in the low state. Like I say, this varies depending on the sort of relay module you have and the way that you have it wired up. Some have a high signal as their default state, in which case that's when the common pin is collected to the normally closed pin. Some have that as a low signal. They vary. If you get kind of the opposite behavior from what you expect, you might need to swap the highs and the lows around in this code. That's all it is. We'll start a serial connection, and we'll output the file name and the date when this script was compiled as well. That's just going to help us with debugging information. And then what we need to do is we actually need to connect to that Wi-Fi network using the credentials which we supplied at the top of the script. So the Wi-Fi name, the SSID here, and the password, which we specified in the constants there, we're going to supply them to the Wi-Fi.begin method. So these are all methods that come from that Wi-Fi library that we included at the top of the code here. And we're going to connect to the wireless network. We are going to wait until we get the successful message code that says WL connected. Until we get that, we'll just sort of loop around and do some ... things. When it's connected, what we'll do is we'll print out the IP address that we were assigned by our local DNS server. And we're going to need to know that IP address because that is the value which we needed to type into our Unity application here. This is the local IP address of the web server that is running on the Wemos D1 Mini. So whatever value is returned by this, that is going to have to match there. And if you're familiar with router configurations, you'll probably want to go to your router and make sure that that is a static IP address that always gets assigned, or at least a reserved IP address, so that that doesn't change each time you turn the Wemos controller off and on again. You want to make sure that it always keeps the same IP address there. Now the next bit we're going to do is we're actually going to assign those callbacks. Remember I said that callbacks are like functions that are triggered when a certain event happens, so we need to actually set up what the events are that are going to cause those callbacks to be displayed. And the first thing we're going to do is we're going to say, well, on this event, so on a forward stroke, so that just means whenever the kind of the top level home page, as it was, if you like to think of it like that, whenever someone just goes to the IP address and doesn't specify any additional parameters, we're going to display that page. Remember, the display page was the callback up here that just gives us this little screen up here. That's nice and simple. However, if the page that they requested was the H, and remember that this was one of the two pages that we possibly requested from our script here from our hand scanner script that's running on the Unity app. Somewhere down here. Remember, we have L and we have H as the two possible pages we request. Well, when it's H, what we're going to do is we're going to write a high signal to the relay pin. We're going to update the last unlock time variable with the current timestamp. And we're also going to update the state of the puzzle to show that it's currently unlocked. Finally, we're going to display the page again. So exactly the same page as we were displaying up here actually gets displayed in every situation anyway. The difference is that all this stuff has happened as well when you display an H. If, alternatively, a client connects and requests the L page instead, which was the other outcome that the Unity application could have done, well, we'll relock the pin. So we'll write a low signal, we'll say that we're locking, and we'll change the state back to locked. And we also assign the not found error handler to the on not found event. So if for whatever reason somebody requests a resource from the server that doesn't exist, so they tried to go to a web page that we haven't defined, something other than this H or L, we will send back that 404 not found error there. And once we've defined those events, what we then need to do is start the server up. So we call the begin method. We'll just output another little debug information. And from this point onwards, the loop function itself, so the main program loop that actually goes round and round as the program is running, is really quite straightforward, because all of those events are handled by this method here, server.handleClient. This is going to deal with all of the connections. So every time a new client tries to connect to the server, every time it makes a request for a resource, anything like that, this handle client will be responsible for making sure that these correct callbacks are fired off in response to the appropriate events. So if a client connects and requests this, we're going to do all this. We're going to give them the display page. We're going to write a high value, all the rest of it. If they request this, we're going to do all these things instead. And all of that is done in a single line of code from just this server.handleClient. So this is a really, very nicely packaged up set of code. And this is all provided, like I say, by these two libraries which we include at the top of our code here. So it's, a lot of work has already been done for you here, basically. The only additional functionality that we want to add in is this bit about relocking the lock again if a certain amount of time has elapsed. So that's just this extra code I've added in the bottom here. If we're currently in the unlocked state, and if the difference between the current time and the time that the door was last unlocked has exceeded the amount of time that we specified at the top, which I think I said was 5 seconds, 5,000 milliseconds, so 5 seconds. So if more than that amount of time has elapsed since the last time the door was unlocked, we're going to automatically relock it again. So we'll do that by writing a low signal and then changing the state back to locked, just to make sure that this doesn't get called over and over again. And that is the very end of the code. So you can see, hopefully, it's actually really quite straightforward. And if you did want to add more conditions, more possible actions that could be performed, what you can do is you can copy these sections of code here, and you can simply add another outcome on the bottom here. So let's say we wanted to, we wanted to add a contact us page, whatever. You could add that here, and now whenever a client tried to connect to the IP address of the Wemos D1 Mini and request this URL after the IP address, this is the section of code that would be executed. So it's really quite straightforward, and they're pretty powerful. You can add a lot of extra functionality with that.
So for the tablet app and the door controller to communicate with each other, they have to be on the same network. And in the code I just showed you, I'm assuming that there is an existing wireless network within range that they can connect to. That's what the SSID and the password in the Wemos code were for.
And if you've already got other wireless props, or perhaps you've got escape room control software that uses Wi-Fi, it makes sense to have these two devices join that existing network. But if you haven't got existing Wi-Fi, that's okay too, because the Wemos on the back of the door here, as well as being able to act as a station that joins a Wi-Fi network, it can actually act as an access point and host its own wireless network as well, like a hotspot that the tablet connects to that instead. So to do that, we just have to make a few changes to the code. Now, in the code I showed you before, the SSID and password variables declared at the top of the code were the security credentials required to log on to an existing Wi-Fi network. But if we're going to host a new wireless network from the Wemos itself, you can call this anything you want. So I've just called it door controller, and that will be the name of the network as it appears to clients who scan for Wi-Fi networks in range and choose which one to connect to. I've also assigned a password. You can see it's not a desperately secure password, but it is still better than having a completely open network. And one thing to be aware of is that the ESP wireless library requires that password to be at least 8 characters long. Now this is something that actually tripped me up for a while because I couldn't work out why my code wasn't working, and I was just trying to assign a password of 1234. And so just so you're aware and don't get stuck in the same hole that I did, make sure that this password is at least 8 characters long. And you'll only need to enter that once into the tablet anyway, and from there you can remember the network credentials anyway, so it will automatically connect to that network. The rest of the code stays almost identical. The only other difference is that when we get it to the setup function, we set a different mode for the Wi-Fi. So before we were setting into station mode. That's where the Wemos was acting as a client to connect to a network. Here we are using access point mode. So this is where other clients connect to the Wemos itself. And rather than calling Wi-Fi.begin, we now call Wi-Fi.softAP to create a new access point. And we'll create that access point using the SSID and password that we specified at the top. And just as before, so before we printed the IP address that was assigned to us by the DNS server on the network, here we're going to print the IP address that we assigned ourselves, essentially, and the default address for that is 192.168.4.1. So going back into your Unity code again, where you assigned the IP address of the door controller to connect to, if you use this approach here of hosting your own wireless network, you can hard code the IP address of the door controller to this IP address here, and it will be able to connect directly to it. And that's the only changes. The rest of it all remains exactly the same. So that just about brings me to the end of this video. I hope you enjoyed this tutorial, and hopefully it gave you some ideas as to how you can use Unity and other hardware devices together to make more interesting interfaces for use in escape room games. Now, as always, I will put the Unity project as well as the code that's running on the Wemos, and both versions of that, so the version that joins a wireless network and the one that actually hosts its own Wi-Fi network. I'll put that over on my Patreon page, and I will link in the description below. I want to say, as always, thank you very much to my Patreon subscribers who support me to be able to create these tutorials. Thank you all very much to all of you. If you do have any questions or comments or ideas as to other kind of props and puzzles you can use in escape room that use a combination of Unity interfaces and physical hardware, I'd always love to read them in the comments below. Otherwise, I will say goodbye, and I look forward to seeing you next time. Okay, cheers, bye.